When we observe reactions in chemistry, it is very helpful to express those reactions as an equation. In equations, the reactants, or what reacts together in the beginning, is found on the left-hand side, and on the right-hand side are found the products, or what the reactants turn into. So the atoms will rearrange themselves and become new things. An arrow is in the middle, and that arrow means yield or yields. So reactants yield products. The formula for each of the reactants is written, and it is balanced with the products. Let's go ahead and try balancing a chemical equation. So looking at this equation, I have lithium, and lithium is a metal, it's a solid, and I am reacting it with phosphoric acid. So S stands for solid. The other thing that you'll see for solid is Cr, meaning it's a crystalline solid, and AQ stands for aqueous. And aqueous means that it's a water solution. So this phosphoric acid has been added to water. On the product side, I have a gas, hydrogen. And remember, hydrogen is diatomic, so it's written H2. And then I have a salt, or a metal put with a nonmetal. And this is a metal put with a polyatomic ion. And it is also dissolved in water. Chemists are lazy, and they tend to drop these species, or what state of matter each of the reactants or products are in, but it is appropriate, if you're going to be complete, that you do include the species. However, I'm not going to mark you wrong if you don't put it, and the AP board also will not, unless they specifically ask for you to do it. Let's go ahead and balance this equation. So the first thing you should know with balancing equations is to save oxygen and hydrogen for last, because they tend to be the most difficult because they can appear in a chemical reaction several times. So I'm just going to start with lithium. So I have lithium on the left-hand side. I have one of them, and there's three over here. So I am going to put a big 3 in front. Notice that you put these coefficients in front of the symbol. Those little tiny numbers are just for writing the formula correctly, so it's in the right ratio. But when you're balancing an equation, then we use the large numbers that go in front of the formula. Once you write the formula, you don't want to go back in and change it. So you get more atoms on a particular side by putting a whole number in front of the reactant or product. So my lithium is balanced. Let's do something else. So my phosphate, my PO4, seems to stay together, and there's 1 and 1, so that looks okay. So let's go and do the hydrogen now. So I have 3 hydrogens here and 2 here. So in this case, I want to do a common number that both 3 and 2 go into, and that number would be 6. So I'm going to put a 2 in front of the one that there's 3, because 2 times 3 would give me 6. And I'm going to put a 3 in front of here. So now I have 6 hydrogens on each side. Now when I do this, that messes up my oxygen. So I need to go back and look at the oxygens. So, or my PO4 group. Now I have 2 PO4s on the left-hand side and only 1 on the right-hand side. So I'm going to put a 2 in front. So that should be balanced. So I have 2 PO4s and 2 PO4s. If you have a polyatomic ion, you can keep, as long as it stays together, you can count it as a group. And this does mess up my lithium. I have to go back, and I'm going to change this to a 6. So now I have 6 lithiums on each side. As soon as I have it balanced, I want to go back and just double check that I have everything. So I have 6 lithiums, that matches, 6 hydrogens, that matches, 2 phosphoruses on each side, and 8 oxygens on each side. So this is balanced as is, 6, 2, 3, 2. We can look at patterns of chemical reactivity. There are different types of reactions. The first type that we're going to look at is called combination or synthesis. Both are acceptable. So this is when I take 2 elements, so element A and B, and I combine them to form a compound, AB. And a good example of this is magnesium reacting with oxygen, and I get magnesium oxide. Looking at this equation, it is not balanced. I can quickly balance it. So I'm going to put a 2 in front here because I had 2 oxygens on the left-hand side, so I need it on the right-hand side. You have to have equal number of atoms on each side, and then I have to put a 2 in front there. Okay. The opposite of synthesis would be decomposition. So this is when I have a compound and I add heat, or something happens to make it break apart, maybe electricity, and I can get its elements. So this one I have hydrogen peroxide, H2O2, and it's broken up into oxygen gas and water. Let's go ahead and balance that. So I'm going to put a 2 here just to even up my oxygens. Sometimes making them an even number makes it easier to balance. So I have 4 oxygens on this side, and so I'm going to put a 2 in front there. And so that gives me 4 oxygens here, and I have 4 hydrogens on each side also. So this is balanced. A combustion reaction is a specific type of reaction where you take a hydrocarbon. So this means that you have hydrogen, carbon, and sometimes you have oxygen too. But at least you have carbon and hydrogen. And then you're going to add it to oxygen, and you're going to get carbon dioxide and water. And you always have these products over here. So it's always CO2, it's always water. So this is an alcohol because it has this OH group like we talked about previously. And let's go ahead and balance it. I think I'm going to just start with the carbons. Again, save hydrogens and oxygens for last. And that's all I have left is hydrogens and oxygens. So let's do our hydrogens. I have 6 hydrogens here. And over here I only have 2. So I'm going to put a 3. So I have 6. And let's count our oxygens. So we have 3 on the left-hand side. And on this side we have 4 plus 3. So I have 7 oxygens on this side. So I need to get 4 more oxygens. So I'm going to put a 2 there. Not a 2, I need a 3. So that will give me 7 oxygens. So 6 plus 1 is 7 on the left-hand side, and on the right-hand side I have 4 plus 3 is 7. So go through and double check, make sure you bounce it okay. 2 carbons on each side, 6 hydrogens on each side, and 7 oxygens on each side. Looking at synthesis, decomposition, and combustion, can you categorize these 4 reactions? Stop the film and do it, and then we'll come back and I'll give you the answers. Okay, we're back. On the first one, we have one substance that breaks up into 2 substances, so this would be decomposition. This next one, there's my hydrocarbon and my oxygen, and I have CO2 and water, so this is combustion. This next one I have 2 things going to 1 thing, so this is synthesis. And this one I have 2 things going to 1 thing, this is also synthesis. All right, let's do a problem where we write the formula and we also balance it. So this is just combining a lot of the things that we've already talked about. And let's start off with this first one. So sodium, this is just the metal. So Na, and it is a solid. And chlorine gas, remember chlorine is diatomic, so Cl2. And then I get sodium chloride. So when I'm making compounds, I need to use oxidation numbers if I have metals. So sodium is a plus, chlorine is a minus, and I just put that together. NaCl, solid. Now to balance it, I only have 1 chlorine on the right-hand side and 2 on the left. So I'm going to have to put a 2 here and a 2 here, and this is balanced. Let's do the next one. So we have lead 2 nitrate. So I know that nitrate is a negative charge, and lead 2, that means it's a plus 2. So when I put that together, I have a plus 2 and a minus 1. I'm going to have 2 nitrates. And because it's a polyatomic ion, you need to keep parentheses around it and then say 2. So notice I do this in 2 steps. I don't do it in 1 step. I'm using oxidation numbers because I have metals. So potassium on this next one is a plus, and chloride, that's a minus 1, and then I just stick it together. A plus and a minus cancel each other. And this one would be aqueous as well with this last one. These are just in solution. Let's look at our products. Oh, I have a precipitate right there. So this is lead 2 again, and chlorine, which is a minus 1. And putting it together, I need to have 2 chlorines. And then I have potassium nitrate. So potassium is a plus 1. It's an alkali metal. Nitrate is a polyatomic ion. You can look it up or you can get it memorized, NO3 minus. And it's a plus 1 and a minus 1. I can just stick it together. I don't need parentheses in this one because it's all by itself. All right, let's go ahead and balance this. I can see I have 2 nitrates over here, so I'm going to put a big 2 in front. And that changes my potassium, so I'm going to put a 2 there. And I think it's balanced. So let's double check. So I have 1 lead on each side. I have 2 nitrates on each side. I have 2 chlorines on each side and 2 potassiums on each side. So this is balanced. So this is a precipitation reaction because I get a solid. And I should put that in there. This is a solid right there. And to finish it off, this last one over here is aqueous. So these are 2 solutions that come together and they make a solid product or a precipitate.